Unit 7, Lesson 3, Graphing Systems of Linear Inequalities. In this opening exercise, we're asked to graph the following system of inequalities. This is very similar to what you did in Algebra 1 Common Core. We're just going to extend the theory of it a little bit more. So y is less than or equal to a negative 2. We're going to graph that line as though it was equal to negative 2. So where y is equal to a negative 2 is a line that goes through or intersects the y-axis at negative 2. And all values for y are less than or equal to negative 2, so it is beneath the line. So shading is down here. So now x is greater than 3. So where x is 3, so where it intersects the x-axis at 3, we're going to represent this line as a dashed line because the inequality does not include an equal sign. And all values for x are greater than 3 is shaded to the right of the dashed line. So the common solution for both of these inequalities is where the cross-hatching happens. It's where the red as well as the black overlap. So is 5 negative 3 a solution? Yes, it is, because it's in the cross-hatched area of where the shading overlaps. Is 4 negative 2 a solution? It is a solution because it's on the boundary line that includes negative 2 as well as the shading for the other inequality. So the answer to B is yes. Is 3 negative 5 a solution? And the answer to that is no, because 3, although is used as a reference point or line, it's dashed, so it's not including 3 in the solution. So we can't use that as a part of the boundary line. So the answer to C is no. And the region is the intersection of how many half planes? It's the intersection of 2 half planes. So that's a new terminology that you haven't seen before in comparison to Algebra 1. We're talking about the shaded regions as being half planes now. As a result, the student outcomes for this lesson is that students describe rectangles with edges parallel to the axis and triangles in the coordinate plane by means of inequalities. Example 1, graph the equation y is equal to negative 2x plus 6. So plus 6 is the y-intercept. So I'm going to designate that on my graph. And negative 2 is the slope. So to this point, the y-intercept positive 6, I'm going to apply the slope of negative 2. So that's down 2 over 1, down 2 over 1, down 2 over 1. It's a solid line. Please use a straight edge when you go ahead and draw the line on your paper, as I am unable to do that. So we want to find the area of the triangle bounded by the given line, the x-axis and the y-axis. So that is this area right here. And we're asked to shade the shape. Now write 3 inequalities to represent the shaded region. So I know already y is equal to negative 2x plus 6. The y-axis is the same thing as x is equal to 0, but it's also shading to the right. So all values for x are greater than or equal to 0. And for the x-axis, y is greater than and equal to 0. So those are the three inequalities that represent the shaded region, and it's a triangular region. Example 2, draw the triangular region in the plane described by the following system of inequalities. So y is less than or equal to 3x. So my y-intercept is at 0. I'm going to apply a slope of 3, so that's up 3 over 1, up 3 over 1. And I do have a solid line because of the equal sign in the inequality. For the second one, y is greater than or equal to 1/2 x. So again, my y-intercept is at 0, and I'm going to apply a slope of 1/2, so that's up 1 over 2, up 1 over, hold on, up 1 over 2. My first or second point here, I didn't do that right. So up 1 over 2, up 1 over 2, up 1 over 2. And then for the third line, I'll do in blue. Y is less than or equal to negative 2x plus 5, so I have a y-intercept at 5. And I'm going to apply a slope of negative 2 over 1, so down 2 over 1, down 2 over 1. And, there we go. So for my blue line, going backwards, all values for y are less than the line, so my shading is down this area. Actually, I don't want to shade the whole thing like we used to. I'm just going to shade the region of the triangle. So shading is below the line. And for the middle one, y is greater than or equal to 1/2 x. Shading is above the line. And then for the first one, all values for y is less than or equal to the line. That's below the line. So that's in this region of the triangle. And there you have it. Example 3. Part A, write the system of inequalities that describes the infinite shaded regions. So we'll start with this line here. The inequality is going to be represented in terms of x, and all values are less than or equal to, where it hits the x-axis at 5. And then for the second line, the horizontal one, I have all values for y are greater than or equal to, because the line is solid, 1, where it hits the y-axis at 1. To describe the region in words, all values for x are less than or equal to 5, and all values for y are greater than or equal to 1. How many half planes intersect to form this region? 2 half planes. Write the system of inequalities that describes the finite shaded region and determine how many half-planes form this region. So for my x values, all values for x are in between, as well as including 3 to 5. And as for my y values, they extend from 2, as well as including that value, to 20.